Welcome to a screencast for factor polynomials by grouping. In this screencast, you're going to learn, wait for it, how to factor polynomials by grouping. We are going to learn how to factor polynomials by grouping because in our future math classes, we're going to be learning how to find zeros of and how to graph polynomials. In order to be ready to learn this lesson, you should know how to factor binomials and have a good understanding of distribution. So let's take a look at a couple of examples. So when we factor polynomials by grouping, the key thing is to make two groups. Now, before I do that, I just want to take a look at my 56a cubed, my 46a squared, the 40a, and the 35. I just want to double check that they don't have any common factors, and they don't. So I'm going to be ready to group. And really, you want an even number in each group. So what I'm going to do is separate this into two groups of two. Now, what I'm going to do is focus on this first group, and I'm going to try and figure out, do they share a common factor? And they do. They share a common factor of 7a squared. So now, what are we going to do? We need to factor out the 7a squared just out of these first two terms. So that would be an 8a plus 7. So, if you distribute, that's what you would get. So we're undistributing, we're factoring. Now I'm going to do the same thing for the last two terms. So what is the greatest common factor of the last two terms? I believe that's 5. And then when you factor out the 5 from 40a and 35, you get 8a plus 7. Now here's a great place to double check your work. When you are done, or when you get to this step, you should have two identical binomials. If you don't, it means that you made a mistake somewhere. If one of these is plus and the other one is minus, there was a mistake somewhere. You need to go back and make sure that you are detail oriented and making sure that all of your signs are appropriate. Make sure that you're factoring out the greatest common factor and not just a common factor. But now that we have this set up and we've got two terms with a common factor, what I'm going to do is factor out that common factor of 8a plus 7. And then my other factor, when you factor something out, you write down the leftovers. So that's going to be the 7a squared plus 5. So this is factored, and we factored with grouping. Now, sometimes this might not be the answer that you see. Sometimes they might want to see the term with the highest degree first. So it might happen that, like in an answer key, you might see 7a squared plus 5 times 8a plus 7. Just be able to recognize that even though you wrote it this first way, you still have a correct answer, even though the answer key might say something different. But either one of these answers would be acceptable on a quiz. Okay, let's take a look at our next example in factoring polynomials by grouping. And again, I'm going to check these terms out, and I do notice right away that they're all even. So I could factor out a 2. But I'm going to look deeper because I want the greatest common factor, and looking at 24, 8, 36, and 12, they do share a common factor of 4. So I'm going to factor out the 4. Now, when you factor something out like right at the get-go, you have to kind of treat it like as a parent or a little brother or sister at the movie. It's important. I mean, if it's a parent, they probably paid for you to get into the movie, but you're going to politely ignore it and just let it hang out and let it be there, but you're not going to let it bother you. And what's going to happen is we're going to continue writing down that 4 as we do the rest of our work. We're just not going to really focus on it again until we get to the very end of the answer. So I'm just going to focus on these 4 main terms and do like I did with the first problem. I'm going to focus on 2 terms at a time. I need to take a look, what is the greatest common factor of those terms? So again, I bring the 4 down, just don't let it bother me. What's the greatest common factor of those 2 terms? It would be 2n squared. So when I factor out the 2n squared out of both of these terms, I am going to get 3n minus 1, because 2n squared times 3n is 6n cubed. 2n squared times negative 1 is negative 2n squared. So there we go. Now, here's that detail-oriented business. When that third term is negative, when this term here is negative. You have to factor out a negative. So even though I clearly see that the greatest common factor of 9n and 3 is 3, I'm not factoring out a 3, I'm factoring out a negative 3. And when I do that, I get 3n minus 1. So I double check my work. I have identical factors. So again, bring the 4 down. I'm going to factor out my common factor of 3n minus 1. And then my other factor is going to come from the 2n squared and the negative 3. Now, when you write your final answer, you don't need to write those giant parentheses. So we would just write 4 times 3n minus 1 times 2n squared minus 3. And that is how you factor polynomials by grouping. So those were 2 examples to help you understand the learning target.